Like when you overhear something that you shouldn't have. All right, everyone. So I do think, oh, thank you. Okay, cool. Let me put this on slideshow view. Okay, we're ready to go. So yeah, I'm just gonna, this is, I'm not gonna start with a no freestyle rap today, sorry. We're taking a different, but I did hear from another speaker that we had another poet in the house. Poets represent. So let's get into the Python. Very quickly about me first. So longtime Python developer, user. You've already seen the slides, like 90s, etc. I write a lot. It's a good way to help people, etc. And my company, Uri Data, is basically helping create AI workloads in consulting context for for other companies. I'm also a poet, DJ. I love to snowboard, etc. That's my daughter there. She sometimes performs with me. She's 14 now, though, so I'm getting to the point where I'm not cool anymore. So, and yeah, so a bit about Uri, but you know what? I'm going to just dive right into it. So, the motivation for this talk is that I discovered modern transformer neural network technology, like late 2022. So I've always been into AI, but I've also always been skeptical that neural networks were going to be the AI mechanism that ends up really making a revolutionary difference, because even when I was in college and I would ask the lecturer, how do neural networks work? He'd be like, or he or she would be like, I don't know. Nobody, and no one still knows how they work. But it turns out they seem to work pretty well. So I was like, okay, well, if you can't beat them, join them. And I started to get involved with Stable Diffusion, Bloom language model. Stable Diffusion is still a thing. Bloom was like revolutionary when it came out. It's a multilingual language model. Now it's like, chump change compared to some of the other ones out there. So I started working with basically in this context of developing AI, large language model pipelines and workflows, like about March of last year. So at first, I was like, LangChain, this is cool. I haven't even heard of half this stuff. What is retrieval augmented generation? What is contextual compression? You guys are probably also, and some of you are also asking, what's all that? These are various techniques that you can use in large language model pipelines. And LangChain is cool because it has a lot of these packaged right in there. But I soon discovered you pay for having all that in one package. It's very complicated. And where that bites you is when it's time to debug, or if you step slightly off the path that they have laid, then you find yourself in the weeds, straight in the bush. So, I ended up developing my own lightweight toolkit, which is, in my opinion, more Pythonic. There's a lot of stuff in the AI world that you can tell that people who wrote this spent most of their time writing Java. There's 10-layer deep class trees with framework this and hierarchy that, etc. So I'll talk a bit more about it, but prefer a lightweight bundle of tools you can pull off the toolkit and you can work with it. So, yeah, the first tool. Oh, I was going to set my timer. Okay, well they'll tell me at least when I have 10 and 5 minutes left. But OgbujiPT, I started working on again early last year, and yeah, there it is on GitHub. Give us a star, help a brother out. But anyway, what it is it's an open source tool that you can use to basically put together simple AI large language model processing pipelines. So it's just helper functions and some classes, etc., with a lot of tasks that are really common. And the idea is to emphasize simplicity and transparency. So when things break down, you can actually quickly trace where they've broken down. And the other thing is, really serious software engineering, taking care of like the non-functional requirements, being conscious of security, being conscious of, you know, the QA requirement and things like that. And hey, let's get the names out there. I heard Bimpe AI earlier, so let's get those native names into the AI space for sure. So that's OgbujiPT, and I'm just going to do a quick, actually, okay, I'm gonna have to bump up my font, I think. Hang on. Okay, let me close this drawer. Okay, and hopefully that's reasonably readable. So here's some sample code that basically, you know, it has an OpenAI chat API. OpenAI ChatGPT is not just, or rather, OpenAI is not just a company that creates ChatGPT and creates DALL-E, et cetera. They also have an AI that's very common for accessing large language models that might be hosted through other systems. So that API is useful because a lot of tools out there already conform to that API. And so in this case, I'm not actually going to use OpenAI. I'm going to use a server that I'm going to run on my little Mac. My travel MacBook Pro is 8 gigabytes of RAM, so you know, you can start saying a prayer for it right now when I start running these AI workloads. It is not built for this, but it works, and that in itself is kind of impressive. Anyway, yeah, so quickly through the code. So it's going to import that stuff, and prompt to chat will take simple text and turn it into a system messages, which the OpenAI API likes. Then we're going to create an instance of that API that we can make requests, establish a prompt, and we're going to call that prompt and get a response, and then we're going to print the first choice, because in theory you can get multiple choices from the large language model. So we're going to print out the first choice that we got. So I'm going to start IPython. Quick question, who here uses IPython? IPython. Show of hands. Not a lot of you. Seriously, try out IPython, especially when you're in like debugging mode and you're really trying to work things out, etc. IPython is really powerful. It has a lot of features that makes it very friendly and easy for a developer to, you know, get in, and it's just basically a more powerful version of the regular Python shell. So yeah, so I'm going to go into IPython, and I can, you know, paste this code in. But I need to run, hang on. I need to run the server, so. Okay, so I'm going to run the server, and I'll be talking a bit more about this, but I'm going to run a model on my laptop, which I've already downloaded, and it's Hermes 2 Theta Llama 3 8 billion parameter 4-bit. There's a lot going on there, so let me break it down a bit. Llama 3 is, so folks have probably heard about Llama. It's basically Meta, sort of Facebook's parent company. It's an open source large language model that Meta has made available. And Llama 3 is the third version of it, and it has an 8 billion parameter version. So 8 billion parameters is kind of how much stuff is stuffed in its quote unquote brain, how much stuff is in there in its knowledge base. You have, you know, some people have estimated that ChatGPT, for example, is, you know, like in the hundreds of millions of hundred of billions of parameters, rather. And so this is just 8 billion parameters, so it's a lot smaller. But that's why I can run on my little travel Mac. Hermes now takes that and adds a lot of new information on it. It's called fine-tuning. So the Hermes, now it's a research company, they fine-tune it to add more knowledge and add more features to it. That's a cool aspect of open source large language models. You can specialize them. So for instance, you could take Llama 3, for example, put in data sets of people, you know, speaking in, I don't know, Igbo, Hausa, Yoruba, whatever, or, you know, even smaller languages. You know, my mom's ancestral language, Uman, has, I think, 18,000 speakers, you know, from the South. So let's get a fine tune for, interacting in Umon, right? Anyway, so you can fine tune it. In this case, they did some stuff to make it pretty useful. And then the 4-bit it's quantized, which means for each floating point value that's in the matrices, because AI is just a whole bunch of matrices, or most AI is, each floating point number is reduced from 16 bits to 4 bits. So that's called quantization. So I'm just going to run that. If I didn't have it downloaded, it would go to Hugging Face. Hugging Face is a very popular repository for AI software, AI models and software and discussion and communities. And it would download all that. But I do have it, so it just launched straight up. And for what it's worth, this model will be about 4 gigabytes of data downloaded. And it uses Uvicorn, which some of you might be familiar with. But anyway, the server's ready, so let's go. So we go to the Python code. It's running on port 8000, and then we run it. So, of course, it's going to make a call using all that to the large language model running on localhost. I don't need to be connected to the internet on my laptop. And, we're waiting a bit for the response because this laptop is working hard to get you this response in its limited 8 gigabytes of RAM. But yeah, so it gives us a short birthday greeting, which is what we asked for, and Bob's your uncle. But anyway, the OgbujiPT part is just like the very simple API. And if you look at the code, it's very transparent. There are not a whole bunch of levels of abstraction to it, which is kind of the point of it. Okay, so now I want to move on to what I think is OgbujiPT is nice, it's functional, but I want to move on to something that I think is pretty cool, even though I do say so myself. Let's go back to the presentation. Okay, slideshow mode. Okay. Well, actually, first of all, before moving on to something else, I do just want to talk about non-magic RAG, as I call it. So RAG is retrieval augmented generation. It's when you take some information from a database or a knowledge base or a vector base and use it to give the large language model, through the prompt, more information to work with. Now, LangChain that's one of the main things that attracted people to LangChain, and another software tool library called Llama Index, was the fact that it had RAG out of the box. But again, it's nice to have it all in the box, but when you start needing to debug or start doing something slightly variant, it's tough because there are many layers of magic to fit it all into that box. So if you look at RAG, it's pretty simple, right? You have an embedding model which allows you to turn text into the numbers the large language models think in, and then you search for information based on the user prompt. You get the results. You put them into the prompt. So here I'm just joining the results, and then loading some prompts, and then creating these system and user messages which contain the information for the large language model to process. And then these last 2 lines are just the code that basically runs the large language model. But it's all right there, and it's pretty straightforward. There's no need to hide it behind a lot of magic. And furthermore, there's something important that I find very lacking in a lot of AI workflows. And that's basically separation of concerns. So how many people, well, I wouldn't ask, but there's a lot of code, and you can even see in the conference, et cetera, where, and even in what I showed, you have code, and then you have prompt equals, and then you have a whole bunch of natural language, right? So in the engineering world, we learned a long time ago you shouldn't do that for a variety of reasons. So for one thing, is just kind of separation of concern. Code is code, natural language is natural language. You just have problems when you combine them together. One of the problems you have is globalization. What if you have to translate the prompts or any other natural language into other languages? Well, if you separate things, so for instance, Python has something called getText, where you can basically separate the natural language that needs translation from the rest of the code. Now you can have things translated. And then, of course, if you have maintenance tools and you have the natural language over here and you have the code over here, you can have the maintenance tools operate instead of having to pick its way through the code to find the natural language to work on. So that separation of concerns is something I would encourage everybody working in AI to think about. You don't have to use, the solution in OgbujiPT, which I call word loom, but just use something to I would encourage you not to just litter your prompts into your code, but separate the prompts out in some way. And like I said, there's a long history of how this could be done in the globalization space that's worth looking at. And then I already talked about how you can design things with monolithic frameworks or with lightweight libraries. Python has tended to lean towards the lightweight library side, and I agree with that. And that's one of the things that makes me a bit leery of large framework-driven libraries like LangChain. So don't forget the traditional software engineering lessons just because you're working in AI. They all still apply. Okay, so yeah, to the to what I think is pretty cool, something I've been working on more recently. And the metaphor I came up with it is, if you give a parrot a toolbox, does it become an ape? So I'll revisit that, and we can let's consider it like a Sphinxian riddle for now. So Tulio, also on GitHub, is a more recent project of mine. And what it is it's a tool that allows, or it's an open source project that allows you to develop basically LLM responses that are structured. So there was an earlier talk by David Okware about, it was steering LLMs towards reliable and structured outputs. So it's kind of like that. The approach that Tulio takes is, it's designed for Macs only, so I should have mentioned that. But it actually uses features or integration with a Mac's graphics layer. It's called Metal. And it uses that to rapidly constrain the results that come back. So if you want JSON, let's say, then you want it to start with like curly brace or square bracket or something like that, right? Well, it will actually do that at the sampling level. It'll say, hey, you don't all of a sudden have all the tokens in language to choose from. You just have curly bracket and square bracket. Now choose, right? So that's the idea of steered. It's basically you're steering the output. So that's the key thing in Tulio. And if you do that, you can get structured output, such as JSON, such as XML, such as, whatever, CSV, etc. And then with that, you can do tool calling, which is when you tell the large language model, hey, go tell me what a stock price is for this particular company. Or, hey, go and turn the lights on in my house, right? You can actually have the AI generate structured commands that can be executed in the real world. It has an OpenAI like HTTP server API implementation, and that's actually what I was using when I was talking about OgbujiPT. And it has a command line client and a Python API. We'll be looking at the command line client with the limited time that I have. So let's take a look at that. Where is that? Okay. So you already saw, actually you can see the interaction from when I generated that last request. But again, this is just the Tulio server running Hermes 2 theta llama 3 8 billion parameter 4-bit, etc. So one of the things you have to think about when you're trying to get large language models to operate tools and generate those responses, they kind of have to be smart enough to do it. Now, something like GPT-4 or Claude, they're definitely smart enough to do it. And that's why tool calling has been in the OpenAI space for a while, because it's such a powerful large language model. The cool thing about what's happening lately and why something like Tulio is possible is large language models that are smart enough to generate structured responses to execute tool calling have become as small as 8 billion parameters, i.e. they can fit on an 8 gigabyte RAM MacBook, right? So anyway, yeah, so that's the server. So you run the server, and then I'm going to start with an example where here's the prompt. Adama went home to Nigeria for the halls. Your answer should only be in JSON according to this schema. What schema? That will be replaced by the second thing, schema countries.schema.json, which is I want back an array of objects. Each object, I want it to have a country and a continent, okay? So I'm asking for it to be restricted to that and nothing else. The LLM shouldn't say, here's your JSON data, and then show the JSON data, because now you as a developer are like, oh, okay, now I got to figure out a way to peel all that away from it. So that's the steered output part. So anyway, if I run that, and I'll make a Twilio request, which is basically just a command line that implements the Python API. I'm calling the local host there. I'm giving it that prompt file and that schema. And so that's, of course, going to hit that server that I just executed. And then it's going to, so when you're trying to do things like extract documents from a form or something like that, you want that data to be structured. And that's why structured text generation extraction is so important. So here it came back exactly in the structure that we wanted, not one more byte of information. Just name, Nigeria, continent, Africa. Now, the fact that continent Africa was not in this sentence, right? Said Adama went home to Nigeria. So it extracted data from the sentence to fill the country, but then it extracted information from its latent knowledge, knowing that Nigeria is in the continent of Africa. And therefore, that was the most natural completion for the LLM to make. And so that's why we have it giving us what we want there. Okay, so here's another quick example. What's the weather like in Lagos today? Now we're going to give it a function. Instead of a schema to follow, we're going to give it a function to call. We want it to call get current weather with a location and a unit, centigrade or Fahrenheit. So let me go ahead and run that. And so, yeah, so that goes back and it tells the large language model, here's a prompt, and here are some functions you can call in case the prompt, in following the prompt, you think you need to call a function. So if you ask an LLM, what's the weather like in Lagos today, it'll be like, I don't know, but oh, there's a function, get current weather with location. There, I can help the user by using that function. So it's going to generate a function call. Now, one thing I want to highlight in what I did there, it says max trips equals 1. That means, so in Twilio, you can tell it, only go to the LLM 3 times, 4 times, 5 times. It's like a control against like the LLM getting confused and like retrying function calls and stuff like that. But we only said max trips is 1. So that means we did the prompt, the LLM requested a function call, and we couldn't go back again. So Twilio is like, okay, we're kind of stuck, but I will tell you, the model invoked the following tool calls to complete the response, but there are no permitted trips remaining. So the LLM said, I want you to call get current weather, the location Lagos, Nigeria, the unit, this I'm pretty sure happens to be Fahrenheit in Unicode, etc. So this is what's happening behind the scenes when you use function calling with, say, you know, ChatGPT or something like that. It's sending these things back and forward, you know, until it gets a final answer. So let's go ahead and get that final answer, or rather, I think I move on to a different, because I don't have this connected to an actual weather app. So in the next example, we're going to use a Python built-in. What is the square root of 256? Well, one way of finding that is by using Python's math.sqrt. So now we're going to have a function calling example where it knows how to get the function call because it's a Python application. It can just import it and run it. So that's where we have here pyfunc math sqrt. So that's a Twilioism. It's not standard part of the OpenAI API. It's something that we implemented in Twilio in order to, you know, extend its ability to call functions. So if we run that, it's still going to take the 2 trips. The first trip is going to generate the function call request to say, give me the square root of 256 using math.sqrt, which we provided here. And the second trip is going to use that to construct a natural language answer for the user. So the final answer is the square root of 256 is 16. And I can actually do a trace. And then run that same command again. And then all the trace will do is it will kind of, well, it'll trace the back and forth that goes on. So yes, calling tool square with args square 256. So it's telling you the LLM is requesting this tool call. The tool responds, basically Python's math.sqrt responds with 16.0. The LLM decides, the user doesn't need the point 0. We'll just say the square root of 256 is 16. This last part is just the LLM generating the final response based on the prompt and based on the information that the tool call generated. Okay, so I think this is the last example. So now, okay, that's cool, but what if Python doesn't already have the function you want? So you can write your own functions and register them. So here's an example of one that just happens. It comes built in with Tulio. It's basically Tulio.tool math calculator, just a simple calculator that basically executes executes a Python expression to get it, which I hope everybody had chills down the back of their spine when I said that, because that's a great example of what's called an injection risk. It's a good way to get, hacked, basically. So it's something I see a lot of AI workloads where you do something like you have the large language model generate, SQL, and then just go ahead and run it against the database. Well, that's great until a user finds a clever way to get the large language model to add, a semicolon drop table at the end of that, and then you got problems. So you do have to be careful. Now, if you look at the code for Tulio MathTool calculator, in the code, it strips out everything that's not plus, minus, slash, star, and digits and dot. Basically whatever you need to construct a number, etc. I'm not even pretending that's exhaustive. So there's still a warning on it saying, just make sure you know what you're doing if you use this. But I wanted to make that broader point. But anyway, so let's get back to what it's actually doing. So, oh, sorry. I want to use the trace. Well, I'll rerun it with the trace. But, oh, no, I was smart enough to build that into the example. Good. So you can see it's calling, it's made one trip to the LLM and it's come back. Calling the tool calculator with, here are the args. Let me expand this window. So the LLM is actually showing us its chain of thought, and some LLMs are really trained to do that. So this is, the first time it goes through, it calls the function to, math.calculator with arguments. Here's the expression, 100 divided by 9.58. So here's the response, right? Now, on the second trip, it now decided to compute a final response. The LLM decided to show all its work, which is kind of cool. And you can see how it broke it all down until it got Usain Bolt's speed. So anyway, that's Tulio in a nutshell. I just want to wrap up with, I think I had a couple of final comments and then questions. Oh, so just quickly. So if you give a parrot Tulio, does it become an ape? And so the joke here is that a lot of people, when they started using like GPT and stuff like that, realized large language models aren't magic. They're not brains. They're not human. They're not smart. They're parrots. They've taken all the text that we've generated, we real humans, and it's just regurgitating them in cool ways. That's all it's doing. It is a parrot. And I think that until we realize that a large language model is a parrot, all the things we're talking about, hallucination, or just when it's, doing weird things, not asking for what you want it to do, we're not going to solve those problems until we realize it's a parrot. So I do think that the future of large language models is tool calling, because then what you can do is have a collaboration between the AI, which is good at parroting language, and tools where you are writing the code for what actually happens. And, some anthropologists would say that the apes are the first one of the species that can use tools, maybe crows, etc. But anyway, that's why I came up with that little saying. So that's all. Any questions? Thank you. Thank you.
So, yeah, thank you so much for this talk. I actually found it very interesting because recently I've been doing a lot of stuff with AI, RAG, agentic, AI, and stuff like that. So, there are a lot of frameworks out there. There's AutoGen by Microsoft, there's LangChain, which I don't like, and then there's Llama Index, which I use a lot. I love Llama Index. So I want to ask, what do you think is the biggest advantage of using Tulio over frameworks like Llama Index?
Yeah, it's a good question. There are a lot of frameworks out there. You mentioned AutoGen, you mentioned LangChain. There's Crew AI, etc. You know, listen, I wrote Tulio, right? It's my baby. I love it. I think just like with OgbujiPT versus LangChain, the greatest solution is simplicity and Pythonicity. Maybe I should have put back into my talk that I've been writing Python since 1996 because that's kind of where I'm coming from. I think I have, I look at these frameworks, a lot of these frameworks, I start debugging them, I start maintaining them, I deploy them for a client and there's a problem and now we're wading through tracebacks that have been completely rewritten. And I just feel a lot of this stuff is not Pythonic. So I really did write Tulio to be very Pythonic from the ground up, and I think it makes it simple, approachable, and readable. Now, let me be honest, it's not as mature as those other tools. Tulio is less than a month old. I started working on it, about a month ago. I think it's pretty cool what it can do, but yes, you kind of have to make that decision. But my argument for Tulio would be easier maintenance. Yes, and contribution and extension. But yes, microphone. Oh, David, sorry. There's one here first. Sorry, I didn't see it.
Yeah. Okay, so I'm going to give you a little bit of a hard time, but not really, because there's actually a point to it.
Why wouldn't you?
Why wouldn't I, of course? Well, so, okay, first footnote, 2103 is degrees Celsius, 2109 is degrees Fahrenheit.
I'm going to start asking him Vulcan Unicode symbols now.
You should have memorized the entire the astral plane. That's not the question. One of the things that I think is lacking in LLMs now is there really isn't a straightforward way to tie them to formal ontologies, which I think a lot of the hallucinations and a lot of the limitations would be answered by exactly that. But in a way, this callback to functions, if you imagine the functions, are tying into formal ontologies, triplets and things like that, could answer that. Have you thought about that in regarding to your toolchain?
Ladies and gentlemen, this is why we invited David Mertz all the way from the USA to talk to us. This man is brilliant. So the question is, one area where LLMs might struggle with a lot of the things, and AI in general, that we throw at it, is it doesn't really have a theory of the world. It has all the language chopped up in it, right? But it does it really know up from down, left from right? Really? It doesn't really. I mean, that's a philosophical question. So there's this idea that all that knowledge, the knowledge of being, ontology as it's called, it was a whole different branch of AI, as a matter of fact. And so David's question is, LLMs seem to be missing that branch, understanding of being at a deeper level than just the chopped up words. Could tools have we thought about how that could happen? And the answer is 1,000,000% yes. And you might know, you said you're giving me a hard time, but you might have actually been throwing me a softball, because David also knows that's the branch of AI I come from more, which is the formal logic and reasoning side. And, tools so if anyone's heard of graph database retrieval augmented generation, that's basically what we're talking about, where you take information from ontologies, which break down the world into simple statements, and then you incorporate that into the prompt, so the large language model has more of an anchor in reality to work with. And yes, Tulio is, I think, for instance, you could connect to an ontology of some sort, and you could now use it to pull back information for the large language model to reliably complete information with correct knowledge.
Thank you very much. Please give him a round of applause.
Okay, thanks.
Round of applause, please. Thank you.
Thank you.